Hello everyone, Assalamu alaikum. My name is
Now,
Vapi.ai and I am a student of Rehan School Kirin campus. So today's we have the Vapi.ai. So let's go and talk to her in conversation the one topic. Hello Vapi, how are you?
hey there, nice to meet you. Your name? And cool, you're a student at the Grand School of Caden campus. I hope you're enjoying your time there. So, today's topic is Pi Personal AI, right? That sounds pretty interesting. I'm here to talk about anything you want, so feel free to dive into the conversation. Just let me know what you'd like to chat about. And if there's anything specific you want me to look up or help you with, just say the word. I'm all ears.
Yes, thank you so much. So can you suggest me today's talk topic?
Hey, sorry to interrupt, but my name is actually Vapi, not Luke. Sure, let me suggest a topic for you. How about we talk about the impact of artificial intelligence on education? It's a pretty cool and relevant topic, don't you think? We can discuss how AI is being used in classrooms, online learning platforms, and even in personalized tutoring. What do you think? Does that sound interesting to you?
Can you suggest me some unique and informative topic related to AI?
Well, of course. Let's dive into the fascinating world of AI. How about we talk about a concept called deep learning? It's a subfield of artificial intelligence that focuses on algorithms inspired by the human brain's neural networks. These algorithms are designed to learn and make decisions based on vast amounts of data. Deep learning has been a game changer in many areas, such as computer vision, natural language processing, and even self driving cars. It's pretty mind blowing how AI can mimic certain aspects of human intelligence, don't you think?
Another topic.
Sorry, it seems there was a bit of a glitch. Could you please phrase or clarify your question? No problem at all. Glitches happen. Let me know if there's anything else you'd like to talk about or if you have any other questions. I'm here to help.
Okay. So can you tell me what is the meaning of deep learning?
Sure thing. When it comes to AI, training is a crucial process. During training, an AI model is exposed to a large amount of data to learn and build patterns and relationships. This data is usually labeled or annotated to provide the model with examples and guidance. The model then uses this data to adjust its parameters and improve its performance over time. The goal of training is to make the AI model capable of accurately predicting or generating responses based on the input it receives. It's kind of like teaching a student and helping them improve their understanding and knowledge.
Thank you so much for your answer. And my another question from you: can you tell me that what is the deep learning? How does it differ from traditional machine learning techniques?
Absolutely. Happy to share more information with you. The new wave of AI, known as deep learning, differs from traditional machine learning techniques in a few key ways. First, deep learning models are based on artificial neural networks that are inspired by the structure and function of the human brain. These networks have multiple layers of interconnected nodes, allowing for complex computations and learning from raw data. Second, deep learning models are capable of automatically learning hierarchical representations of data. This means they can learn to extract and understand features at different levels of abstraction. Allows for more powerful and flexible modeling compared to traditional machine learning methods that rely on handcrafted features. Lastly, deep learning models rely on large amounts of labeled data for training, which typically requires more computational resources. Traditional machine learning techniques often require more manual feature engineering and may not scale as well to large and complex datasets. So, in summary, deep learning brings the ability to learn from raw data, automatically extract features, and scale to large datasets, making it a game changer in AI research and applications.
Okay, Rafi, thank you so much for your answer. And my another question from you: can you tell me that what are some common architectures? What are some common architectures used in deep learning, such as convolutional, natural networks, and CNNs, and recurrent neural networks? And what are their applications? I think she disconnected.
Oh, hey, sorry I must have dozed off for a second there. Welcome to Vapi. I'm an AI assistant that you can talk to like a person. So, how's your day going?
Yes, my day is going very perfect. My question from you basically, what are some common architectures used in deep learning, such as convolutional neural network and recurrent neural networks, and what are their applications?
Oh, okay. So I think you're asking about common activation functions and optimizers used in deep learning neural networks, right? All right, let's start with activation functions. These are mathematical functions that introduce nonlinearity into the neural network, which helps the model learn complex patterns. Some common activation functions are one, ReLU rectified linear unit. It returns the input if it's positive and zero otherwise. Two, sigmoid. It squashes the input between 0 and 1, which is useful for binary classification problems. 3. Tan hyperbolic tangent, it squashes the input between -1 and 1, which is useful for bounded outputs. 4. Softmax. It converts a vector of real numbers into a probability distribution, commonly used for multi-class classification problems. Now let's talk about optimizers. These are algorithms that help the neural network adjust the weights and biases during training to minimize the loss or error. Some popular optimizers include 1. Stochastic gradient descent (SGD). It updates the weights based on the gradients of the small batches of training data. 2. Atom. It adapts the learning rate for each parameter based on the past gradients, which
Uh,
How's your day going?
Yes, my day is going very perfect. And so my another question from you. Can you tell me that how does back propagation work in deep learning and why is it important?
Well, that's an interesting question. In game learning, a bad or improper question can disrupt the learning process and hinder the player's progress. It's important to ask clear and well designed questions because they help guide the player's understanding and encourage critical thinking. If a question is ambiguous or confusing, it can lead to frustration or misunderstanding. So it's all about creating a um sorry, I think you got cut off there. Could you please continue with your question?
Okay, thank you so much, Vapi. So my another question from you. Can you tell me that what is the vanishing gradient problem and how does it affect deep learning models?
The vanishing gradient problem. It's like a sneaky little gremlin that can cause some trouble in deep learning models. When we train neural network multiple layers, the gradients or slopes of the loss function can become smaller and smaller as they propagate backwards through the network. This vanishing gradient can make it difficult for the early layers to learn effectively. The problem is that when the gradients become too small, the model's parameters don't get updated properly, making it harder for the network to learn from the training data. This can lead to slower convergence or even the complete failure of the training process. Now, how does it affect new models? Well, with the advent of deeper and more complex models like GPT-3, 5 Turbo, the vanishing gradient problem can still rear its ugly head. Since these models have a lot more layers, the gradients have an even greater chance of vanishing, which can make training them more challenging. However, researchers have come up with clever techniques to mitigate the vanishing gradient problem, such as using different activation functions, normalization techniques like batch normalization techniques, and more advanced optimization algorithms. These techniques help address the issue and allow us to train these deep models effectively. So, while the
Okay, thank you so much for your answer. And my another question from you. Can you tell me that how do you handle overfitting in deep learning models?
embeddings, those little bundles of information that make our models tick. When it comes to handling embeddings, Vapi takes an approach that's both efficient and effective. First, we use high quality pre trained embedding models like Word2vc, Glove, or BERT, which have been trained on large amounts of text data to capture semantic relationships between words. These models help us represent words or even longer chunks of text as dense vectors in a high dimensional space. Now, to fit these embeddings into our models, we use techniques like dimensionality reduction to reduce the size of the embedding space, ensuring that the vectors can fit into the computational memory more easily. We also consider memory constraints and optimize for speed. Additionally, with the use of streaming and co-locating servers, we ensure low latency while handling these embeddings. So whether it's understanding the meaning of words or processing longer text inputs, Vapi handles embedding models like a pro.
Yes, and Vapi, thank you so much for your answer. And my another question from you. Can you tell me that how do you what are some common activation functions used in deep learning and how do they impact model performance?
Activation functions, those nifty little guys that add nonlinearity to our deep learning models. There are several popular activation functions used in deep learning, each with its own characteristics and impact on performance. Let me give you a quick rundown. 1. Sigmoid, this activation function squashes the output into a range between 0 and 1. It's great for binary classification problems, but it suffers from the vanishing gradient problem we talked about earlier. Not so great for deeper models. 2. ReLU rectified linear unit, this one sets all negative inputs to 0 and keeps positive inputs as is. It's simple and computationally efficient, which makes it a popular choice for many deep learning models. ReLU has helped alleviate the vanishing gradient problem and has shown better performance in sigmoid. 3. Leaky ReLU, similar to ReLU, but it allows a small, non-zero gradient for negative inputs. This helps prevent dead neurons and can improve performance, especially in cases where ReLU might lead to a lot of dead neurons. 4. TAN, this activation function squashes the output between -1 and 1. It's useful for models that require outputs with negative values. It suffers from
Okay, thank you so much for your answer. And my another question from you. Can you tell me that um, explain the concept of transfer learning and its significance in deep learning?
AI assistant that you can talk to like a person. So,
Yes, sir. My other
how's your
question
day
from
going?
you, explain the concept of transfer learning and its significance in deep learning.
Transfer learning. That's a great question. So, transfer learning is a technique in deep learning where a pre trained model is used as a starting point for a new task. Instead of training a model from scratch, we leverage the knowledge and representations learned by the pre trained model on a large dataset. Transfer learning is efficient because it saves us a lot of time and resources. By using a pre trained model, we can avoid the need to train a deep neural network from scratch, which can be computationally expensive and time consuming. Plus, pre trained models are usually trained on vast amounts of data, so they have already learned useful features and patterns. With transfer learning, we can apply the pre trained model's knowledge to a new, smaller data set related to our. We'll only need to fine tune the pre trained model on this smaller data set, which requires much less data and training time. This approach can help us achieve good performance even with limited labeled data. So, transfer learning is like getting a head start by standing on the shoulders of giants. We can take advantage of the knowledge gained from training on large scale data sets, making deep learning more efficient and effective for a wide range of tasks. Pretty neat, huh?
Yes, thank you so much for your answer. And my another question from you, what role does data processing, processing play in deep learning, and what are some common techniques used?
Got it. So, data processing is a critical step in machine learning where we transform and prepare raw data so that it can be used for training or inferencing our models. However, sometimes data processing can hit a bump in the road and encounter failures. When that happens, it can cause all sorts of issues like incorrect model output. There are some common techniques we can use to handle data processing failures. One technique is called error handling, where we implement mechanisms to catch and handle errors gracefully. This can include things like logging error messages, providing fallback options, or even retrying failed processing steps. Another technique is data validation, where we check the quality and integrity of the data before processing it. This involves tasks like checking for missing values, validating data types, and ensuring data consistency. By validating the data upfront, we can catch any potential issues early on and prevent failures later in the pipeline. Additionally, we can use techniques like data normalization, where we scale and normalize the data to a standard range. This helps in cases where the data has variations or outliers that might affect the performance of our models. So, by implementing error handling, data validation, and normalization.
Okay, thank you so much for your answer. And my other question from you, can you tell me that what are generative adversarial networks and how are they used in deep learning?
Sure thing. Generative adversarial networks, or GANs for short, are a type of deep learning model used for generating new data that resembles a certain input data distribution. They consist of two main components, a generator and a discriminator. The generator tries to produce data that looks similar to the input distribution, while the discriminator tries to distinguish between the generated data and real data from the input distribution. This dynamic between the generator and discriminator creates a competition or adversarial relationship. The generator tries to improve its generated output to fool the discriminator, while the discriminator tries to become better at distinguishing real from fake data. Through this adversarial training process, the generator gets better at generating realistic data, while the discriminator becomes more effective at distinguishing real and generated data. GANs are used in various applications such as image and video generation, text generation, even voice synthesis. They have garnered a lot of attention in the deep learning community due to their ability to generate a highly realistic and diverse data. So, in a nutshell, GANs are deep learning models that use adversarial training to generate new data that look similar to.
Okay, thank you so much for your answer. And my another question from you, can you tell me that what is reinforcement learning and how does it relate to deep learning?
Absolutely. Reinforcement learning is a type of machine learning that focuses on training an agent to make sequential decisions in an environment in order to maximize a certain reward. So, in reinforcement learning, the agent interacts with the environment, takes actions, and receives feedback in the form of rewards or penalties based on its
and explain the concept of RNNS and their application in sequential data analysis. Yes, anyway,
Welcome
another
to
question
Vapi.
from you.
I'm
Can
an
you
AI
tell me
assistant
that
that you can
explain the
talk to like a
concept
person.
of
So,
RNNS
how's your day
and
going?
their applications in sequential data analysis?
Oh, sequential data analysis, huh? You're diving into some interesting stuff. Well, sequential data analysis is the process of examining data that is ordered or has a temporal component to it. It's used in various fields like natural language processing, time series analysis, genomics, and even financial markets. One common application is in natural language processing, where sequential data analysis helps with tasks like language modeling, machine translation, and sentiment analysis. It helps the models understand the order and context of words in a sentence and enables them to generate coherent and contextually appropriate responses, like what I'm doing right now. In time series analysis, sequential data analysis helps with tasks like forecasting, anomaly detection, and pattern recognition. By analyzing the order and patterns in the data, we can make predictions or identify unusual behavior in the time series. In genomics, sequential data analysis is used to analyze DNA sequences and identify patterns or variations that may be related to diseases or genetic traits. This helps in understanding the structure and function of genes and can have implications in personalized medicine. And in financial markets, sequential data analysis is used to analyze stock prices, market trends, and trading patterns. By examining the order and timing of trades, analysts can make informed decisions.
Okay, thank you so much for your answer. And my another question from you, can you tell me that what is attention mechanism and what is attention mechanism in deep learning and how is it used in natural language processing?
Sure thing. Mimics the human ability to focus on specific parts of information. In the context of natural language processing NLP, attention refers to the mechanism that enables models to weigh the importance of different words or parts of a sentence when making predictions or generating outputs. Let's say we're working on a language translation task. When translating a sentence from one language to another, certain parts of the input sentence may have a higher impact on generating the correct translation. Attention helps the model identify and focus on those important parts. The attention mechanism works by assigning weights to each word in the input sentence based on its relevance to the current context. These weights indicate the attention or importance given to each word during the translation process. By considering the weighted inputs, the model can generate more accurate translations. One popular method for incorporating attention in NLP is the transformer architecture, which has been a game changer in tasks like machine translation, text summarization, and question answering. Transformers use self-attention mechanisms to capture relationships between words and extract context-aware representations. So in summary, attention in deep learning and NLP is a mechanism that allows models to focus on relevant information while processing sequential data like sentences. It.
Thank you so much, Vapi, for sharing some insightful knowledge with my viewers and to me. And thank you so much for your time.
I'm sorry, it seems like there might have been a bit of confusion in your message. Could you please rephrase or clarify your question?
No,
I
I'm
want to
not.
make sure I understand what you're asking.
Yes, but I am not asking you a question, but I am thankful to you to giving me interview. Thank you so much. I am thankful to you.
Oh, I see. I apologize for the misunderstanding.
No, thank you so
Thank you
much,
so much for your
viewers.
kind words.
Thank you so much, viewers. Bye bye.
You're welcome. It was my pleasure to assist you.